Hi, I'm Dr. Manimala Selvinaika. I'm a consultant histopathologist and statistician, and my area of interest is in meta-analysis. Now, for this video, I was asked about calculating sample size. So, let me refer to a publication in 1991 by World Health Organization. The title of the book is Adequacy of Sample Size in Health Study, and it's written by Stanley Lemishaw and David Hosmer. So they are very famous statisticians, right? I will put a link to this book below. Now, I'd like to draw your attention to page 52 in the book under the heading sample, right? Now, all the sample size calculations given in the book are meant for probability samples. Okay, you can't use those sample size calculations and the attendant reliability statements for non-probability samples. Okay, now unfortunately most medical research or most clinical research are done on non-probability samples. Okay, so let's talk about what this probability sample is. Now, I'm not going to go into the mathematical theory because that will be difficult for a lay person to understand. So, I'll just explain it using an example. Now, let's say I want to know the average height of students in Subang Jaya Secondary School. Okay, it's very simple. I go and speak to the headmaster and find out that there are 1,000 students there. So I ask him for a list of names of all 1,000 students. Now that list of names is my sampling frame, right? And those 1,000 students are my population. So I will go and measure each student and come to an average. The average is 160. So that 160 cm is my parameter value. Now we call it a parameter because there is absolutely no uncertainty attached to that parameter value. 160 is the correct average of that population because we have measured every single one of them. So let's say I am a poor researcher and I don't have enough time, I don't have enough money, and I don't have enough staff to measure these 1,000 students. But I want to measure them and quickly publish a paper. So what will I do? I will use statistics to get a estimate, right? So what will I do? I will go and get the sampling frame containing the 1,000 names of the population of students, and I will do a probability sampling and get a sample. Then I will measure all the units in my sample. Let's say I've taken a sample of 100 and the average of the sample is known as a statistic. Now we must remember, when we sample from a population, even though we are doing a random sample is not necessarily a representative sample. A random sample can be wildly different from the population itself. You could have just taken one group of students who happen to be too tall or too short, right? So in my sample I get an average height of 155 cm. So that is known as a statistic, right? So we know that random samples are not necessarily representative. So all random samples can come with a statement of reliability. How reliable are these results likely to be? Okay, so the usual one that we put in is the confidence interval, usually a 95% confidence interval, and a probability value, what we know as a p-value, about 5%, right? It's just the opposite of the confidence interval. So a p-value of 0.05. So this entire thing of drawing a sample of 100 students from a population of 1,000, calculating the average and calculating a confidence and interval and p-value is known as a experiment, right? So we have done one experiment. So now let's talk about how we draw the random sample. Now this random sample goes by multiple names. It can be called a random sample, it can be called a probability sample, but more correctly it should be called an independent and identically distributed sample, IID sample. Now what does this mean? This means that I put all the 1,000 names into a bowl. Then I put my hand into the bowl, give it a good stir and pick up one name. Okay, I picked up student number 22. Then I call him and record his height. Now what do I do with his name tag now? If I put it into a separate bowl, now that bowl of population now is not the same as when I sampled the first student, because it had 1,000 names there. Now it only has 999 names. So it is not exact. So the second student I'm going to draw the name from is not going to come from the same distribution as the first student I drew the name from. So what do I have to do? I have to put back student number 22 into the fish bowl, give it a good stir again and pick up another number. So let's say I've got student number 45 now. I call him, record his height and put the 45 back. Okay, so I make sure that I always keep that bowl exactly the same with 1,000 students in it. Now can number 22 come out again in the next draw? Yes, it can. Okay, so that is the meaning of an independent and identically distributed sample. Now what do we mean by independence? Is because I have put back student number 22, the next student I draw, number 45, will have the exact same possibility of being drawn as student number 22. Suppose I had taken student number 22 out of the bowl. Then instead of a probability of 1:1,000, now student number 45 will have a probability of 1:999. So that's why I have to put them back into the bowl. So that is what you call as a random or sample or probability sample or an IID sample. Now when you want to make all this reliability statements like your 95% confidence intervals and your p-values, you have to have an IID sample. Now there's a lot of confusion about this out there in the internet. So if anyone disagrees with me, please let me know. Now, so this act of drawing 100 students, recording their name, getting an average and calculating a p-value and 95% confidence interval is one experiment. So now you're going to ask me, now can I make any reliability statements? Can I make any p-value or confidence interval statements about my one sample? The answer to that is no. Okay, for your one sample, you do not know whether you are right or wrong. So your confidence interval and your probability statement is made per 100 samples, per 100 experiments, right? So that means that experiment that you did earlier, you have to repeat the entire process 100 times, and only then can you make a confidence interval or a probability p-values statement, right? So I will explain confidence intervals and p-values in another video, because I don't want to make this video too long, right? So now that we have done this experiment, we will realize that in most medical samples we cannot recreate this experiment, right? There is no way we can draw an IID sample for most clinical or medical studies. So it's very difficult for us to calculate things like sample size and confidence intervals and p-values for non-probability samples. Now, where did this confusion of calculating sample size for non-probability samples come from? I suspect it also came in the 1990s. Now in the 1990s, the drug regulators such as the FDA and the Japanese drug regulators came together with the drug manufacturers, pharma, to form a council known as the International Commission for International Council for Harmonization, ICH, right? So basically what they try to do is try to be fair to both the drug manufacturer and to the patients in need of this drug. We know that drug manufacturers spend billions of dollars manufacturing these drugs and testing out these drugs. So you need to be fair to them, because if you shut them down, then there is no one to come up with new drugs. And you also must be fair to patients, because there are many patients waiting to try out these drugs. So you need to be fair to both parties. But at the same time, you have to prevent drug manufacturers from making spurious claims which can injure patients. So most drug approvals are divided into two parts. One is the safety aspect and the other is the efficacy aspect. So what I'm going to explain now is a very stylized or very broad version of what happens. So what the regulators like FDA will tell the drug manufacturers is, okay, I want you to do 20 small studies, one in Japan, one in India, one in China, like that, different places. And for the safety data, I want all 20 studies to show that this drug is safe, right? So safety data takes into account all the studies. But for efficacy data, so long as you can show 2 studies which show some efficacy, that means you are not lying. If you say that this drug can cure cancer, you are not lying. It may not cure cancer in every single patient, but at least in some patients it can cure cancer, right? So drug manufacturers have to show efficacy in just about 2 studies, but they must show safety in all the 20 studies, right? So these sample size calculations were broadly agreed upon in the ICH document. Of course, FDA knows that it is very difficult to draw IID sample and calculate sample size and 95% confidence intervals and p-values for human populations, right? You can't do it. But they just wanted to have a general framework to be fair to the manufacturer and to the patients. So they decided that this is how they were going to do it. So they just borrowed the sample size calculation from the WHO book, even though they could not have possibly drawn a probability sample, right? Now, I think a lot of people misunderstood this, that this is a regulatory design framework. It is not necessarily an accurate framework, right? And many people started so-called calculating sample size based on the ICH protocol. And of course, this is going to give you very, very small samples, because the ICH was designed to have for 20 different studies scattered across the globe, whereas you are only doing one little study in your institution. Okay, so I think a lot of people misunderstood the sample size calculation, because the pharmaceutical companies were calculating sample size, but they were doing it because of a regulatory requirement, not because it was an accurate way of doing it. There was just an agreed upon system to be fair. So I feel, looking at the clinical papers, I think that this misunderstanding actually stemmed from doctors not understanding the ICH regulations. So to reiterate, there is no way of calculating sample size unless you can draw IID sample. For that, you need to know the population, you need to have a sampling frame, and you need to repeat it 100 times if you want to make statements about reliability, like your 95% and confidence intervals and your p-values. And it's very rare for a clinical sample to fulfill any of these requirements. So basically most of our sample size calculations are just a misunderstanding of an agreement between pharma and regulators for approval process. Okay, so in the next video I will explain 95% confidence intervals and p-values in plain English so that lay people can understand. I think I've covered most things. So before reading any sample size calculation book, you may want to go through the WHO book, and you can show this around. You can show this video around to any mathematician you know and ask them if they agree with what I'm saying. If they don't, they can leave a comment below. Thank you.